Hello, everyone! In today's lesson, we'll be learning the sum and difference identities for sine and tangent, and how to apply these to evaluate trig expressions and verify other identities. As in previous lessons, make sure you have all your reference sheets from this unit with you, as we will be using them throughout the lesson. At the start of your lesson, you had the pre-video activity, Sine of a Sum. If you haven't had a chance to work on it yet, pause the video to do that now. Let's check your work. The pre-video activity asked us to find a formula for sine of a sum, and it showed us how we can use a cofunction identity to rewrite sine of alpha plus beta in terms of cosine, which we can then consider as the cosine of the difference pi over 2 minus alpha minus beta. Using the cosine of a difference identity from the previous lesson, we can rewrite this cosine as cosine of pi over 2 minus alpha times cosine of beta plus sine of pi over 2 minus alpha times sine of beta. How do you think we can simplify this expression further? These expressions remind me once again of the cofunction identities. We can replace cosine of pi over 2 minus alpha with sine of alpha and sine of pi over 2 minus alpha with cosine of alpha. This results in our sine of a sum identity. Record this identity in this slot of your reference sheet. Pause the video to do so now. Now, let's find the sine of a difference identity. Using the sine of a sum identity, how could we figure out the identity for sine of a difference? If we rewrite sine of alpha minus beta as the sine of the sum of alpha and negative beta, we can then apply the sine of a sum identity. Try to do this on your own, and then simplify the result using the even-odd identities. Pause the video now. Applying the identity, we get sine of alpha times cosine of negative beta plus cosine alpha times sine of negative beta. Then, applying the even-odd identities and simplifying, we get that sine of alpha minus beta equals sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Record this new identity in this slot of your reference sheet. Pause the video to do so now. Let's apply these new identities to the following example. Let's find the exact value of sine of 465 degrees. Give it a try on your own. Make sure to have your unit circle and your identities with you. Pause the video now. First, I notice 465 degrees is over 360. If we want to work with smaller numbers, remember the periodic identity allows us to add or subtract 360 degrees however many times we want. Subtracting 360 from 465, we get sine of 105 degrees, which will be the exact same value because we simply turned back a full rotation. Now let's look at our unit circle. Since 105 degrees is not a special angle we have, maybe we can find a combination of special angles that add or subtract to 105. One option is 60 and 45. Since 105 equals 60 plus 45, we can evaluate sine of 105 degrees by applying the sine of a sum identity, which ends up giving us square root of 6 plus square root of 2 all over 4. It's time to find the remaining two identities of our set of sum and difference identities, the tangent of a sum and tangent of a difference identities. Let's start with tangent of a sum, or tangent of alpha plus beta. How do you think we can find this identity, keeping in mind the identities we already know? Since we already know the sum and difference identities for sine and cosine, rewriting this tangent in terms of sine and cosine would be a great place to start. Using the quotient identity, we know tangent of alpha plus beta is just sine of alpha plus beta over cosine of alpha plus beta. Since we have identities for both sine and cosine of a sum, we use them to expand the numerator and denominator. Now, our goal will be to simplify this fraction a bit and write it back in terms of tangents, not sines and cosines. To do so, we will divide numerator and denominator by cosine of alpha times cosine of beta, which will divide both terms in the numerator and both terms in the denominator. This will allow us to do some nice cancellations and leave us with several fractions of the form sine over cosine, which, using the quotient identity, we can rewrite as tangents. Therefore, tangent of alpha plus beta equals tangent of alpha plus tangent of beta, all over 1 minus tangent of alpha times tangent of beta. Record this identity in this slot of your reference sheet. Pause the video to do so now. Now, let's find the tangent of a difference identity. On your own, use the tangent of a sum identity to find the tangent of a difference identity. Feel free to refer back to how we found the sine of a difference identity and take a similar approach. You will also need the even-odd identity for tangent to do some simplifying. Pause the video and try it out now. Just like with sine of a difference, we can rewrite alpha minus beta as the sum of alpha and negative beta, which allows us to then apply the tangent of a sum identity. Simplifying the tangent of negative beta with the even-odd identity, we get tangent of alpha minus tangent of beta, all over 1 plus tangent of alpha times tangent of beta, giving us our tangent of a difference identity. Record this identity in this slot of your reference sheet. Pause the video to do so now. Let's apply our new tangent identities to another example. Let's evaluate cotangent of 17 pi over 12. Using what you've learned in this unit so far, try to work out this problem yourself. Pause the video now. Since 17 pi over 12 is not one of the special angles in our unit circle, we want to find a combination of special angles that add or subtract to it, which is more easily done if the angle measure is in degrees. Converting 17 pi over 12 to degrees, we get 255 degrees, which can be obtained by adding 120 degrees and 135 degrees. Remember, there are other combinations that can work, so if you chose a different combination but ended up getting the same answer, that's great. Now, how can we evaluate cotangent of 120 degrees plus 135 degrees if we don't have a sum identity for cotangent? We only have sum and difference identities for sine, cosine, and tangent. Could we maybe rewrite cotangent in terms of sine, cosine, or tangent? Of course! One approach would be to use the reciprocal identity cotangent of theta equals 1 over tangent of theta, which means our expression equals 1 over tangent of 120 degrees plus 135 degrees. Now, we can apply the tangent of a sum identity. Since 1 over a fraction is simply the reciprocal of the fraction, we can rewrite this whole expression as just the reciprocal of the tangent of a sum. Then, using the unit circle, we evaluate tangent of 120 degrees and tangent of 135 degrees and simplify the signs. We can further simplify this expression by rationalizing the denominator. Combining like terms and then dividing both terms in the numerator, and we end up with 2 minus square root of 3. We'll wrap up our lesson with one last example. Let's verify this identity. Do you think we should work on the left side, the right side, or both sides? Since both sides are somewhat complex expressions, we should manipulate both sides and break them down with the identities we've learned. Using your reference sheets, determine which identities we should use to expand each side. Pause the video and do that now. On the left side, we can apply the sine of a sum and sine of a difference identities. It would also be helpful to rewrite the cotangent in terms of sine and cosine, which we can do with a quotient identity. On the right side, we can apply the cosine of a sum and cosine of a difference identities. On your own, try to verify the identity by applying all these identities and then simplifying as needed. Pause the video now. We apply the identities and simplify the signs on the right side. On the left side, we cancel out cosine of A times sine of B, and on the right side, we cancel out cosine A times cosine B. Then we combine some like terms, and on the left side, we rewrite the division by cosine of B over sine of B as a multiplication by the reciprocal. Then, we can cancel cosine of B on the left side, which leaves us with 2 sine of A times sine of B on both sides. Identity verified. Today we learned 4 new identities, which you should have recorded in your reference sheet. The sine of a sum and sine of a difference identities, and the tangent of a sum and tangent of a difference identities. We learned how to use these identities to verify other identities and to find the exact trigonometric values of the angles that are either the sum or difference of special angles. Once you've completed your guided notes, complete the additional practice. After that, make sure to complete the online practice. See you next time.
Hey, hey.